Welcome to this lesson, which is a little bit more on parallel and perpendicular lines and also about collinear points. Let's start with a warm-up as we usually do. So find the distance and the midpoint of these two coordinates right here. So remember, the first thing we need to do, label one of the coordinates x1, y1, label the other coordinate x2, y2, as we've done here. x1, y1, x2, y2, very important. Then you are going to start to find the distance. Let's find the distance first. Try to remember, what does the formula look like? That's right, it looks like this. So it's the distance, it's kind of based on the Pythagorean theorem, as we said. So it's big square root y2 minus y1 all squared plus x2 minus x1 all squared. Doesn't matter if you've got x2 minus x1 here and y2 minus y1 here, because you've got a plus in the middle. But what has to be the case is you need to have a subtract in here. Okay, so now we have to just plug in the numbers. Y2 minus y1 all squared plus x2 minus x1 all squared. Make sure to show this substitution step. It's very, very important in terms of getting your method mark. You could possibly plug it straight into the calculator now. If it was a non-calculator paper, you would have to start to work it out yourself. This would be an example of a calculator one though, because if you plug this into the calculator, as we said, you can go straight to just putting in the square root if you like. And then you can start to pop everything in there. Just remembering this is a subtract sign and this is a negative. So subtract and negative. And you get 3.4 rounded to 3 sig figs. You might want to write the unrounded answer and then round your final answer to 3 sig figs. Have a think, have we finished the question yet? And that's right, no we haven't, we need to find the midpoint. So midpoint formula, we want to know what is the coordinates of the midpoint of these 2 points. So remember, the answer to the midpoint is a coordinate. We use capital M. So try to remember, basically, the x-coordinate, you find the average of the 2 x-coordinates, and to find the y-coordinate of the midpoint, you find the average of the 2 y values that you've been given. So that's what this formula is all about. Remember, you use uppercase M. Very important to use uppercase M for midpoint, because lowercase m stands for the gradient. So make sure that you're using uppercase M. So x1 plus x2 over 2, so we're finding the average of these 2 values. y1 plus y2 over 2, we're finding the average of these 2 values. And then you need to plug in the values to get your substitution mark. Plug these in. And then remember, you can use your calculator. You can make nice fraction buttons. So you can use this nice fraction button here. Oops. Let's clear that. Oops. Sorry. Okay. Just clearing that, yet. So now we want to use the nice fraction button, which is right here. Oops, something's going wrong for me here. I don't know what I've done wrong. Anyway, so that's what you would do. You would use the nice fraction button. So I think I know what I'm doing wrong here. There we go. Okay, you would use the nice fraction button. Negative 3 plus 9, for example, over 2. And you would work out that answer. You get 3. And then you would work out this answer separately too. You would go control this, then you would plug it in. 4 plus negative 2 all over 2. Enter. So 3 and 1 are our answers. So this would be could also be a classic non-calculator question. You could have worked this out on a non-calculator paper fine, because negative 3 plus 9 is 6, 6 divided by 2 is 3, 4 plus negative 2 is 2, 2 divided by 2 is 1. And that's the warm-up finished. Now let's move on to the lesson. So more on parallel and perpendicular lines. Here's a little example. Find t, given that the line joining this coordinate to, so the coordinate d, negative 1 and negative 3, find t given that the line joining this coordinate to c, 1 and t, is perpendicular to a line with gradient 2. So interesting to try to think, how would we go around that? So you're asked to find what t is. It's the missing y aspect of the coordinate of c. And remember, what do we remember about, first of all, parallel lines? So what's special about the gradient of parallel lines from last lesson? Have a think. That's right, they have the same gradient. If they're perpendicular, what is the case between what's the relationship between the gradients? I think they are the negative reciprocal of one another. Another thing is, if they're perpendicular, then if you multiply the gradients together, you would get negative 1. two ways of thinking about it. So remember, parallel means kind of like this, perpendicular means crossing at right angles. So we're told that there's a line with gradient 2, and we're told that this line, DC, is perpendicular to it. So try to think what the gradient would be. So if the gradient of the other line is 2, we can express that as a fraction, 2 over 1. What would be the negative reciprocal of that? Have a think. That's right, it would be negative 1/2. So the gradient of CD must be negative 1/2, which is a negative reciprocal of 2. Remember, negative reciprocal, you express this as a fraction if it's not already expressed as a fraction, and then you flip it. So you flip it and you change the sign. So we're told, therefore, that the gradient of this and this must be negative 1/2. And so what you can do is you can plug these into the gradient formula and set the gradient formula equal to negative 1/2 and then solve for t, the missing one. So gradient formula, remember what it is? It's rise over run. So y2, so use the gradient formula is like what we said. So we've got the gradient of CD, remember lowercase m for the gradient, don't use the uppercase m, is equal to negative 1/2, which is equal to y2 minus y1 over x2 minus x1. Make sure you label one of them x1, y1, label another one x2, y2. Doesn't matter, you could have labeled this one x1, y1 and this one x2, y2 as well. That would have been fine. I just happened to label it this way. And the reason why I did label it this way is so that my unknown, my t, is on the top. It's in the numerator, which for me personally is a little bit easier to solve. If you did it the other way around, then the t would be in the denominator, which is fine because you're just going to cross multiply anyway. So if you had negative 3 minus t in the denominator and negative 1 minus 1 in the numerator, you would still just cross multiply and get the same answer. So don't worry if you were doing it that way, keep going. So negative 1/2, which is the gradient, equals y2 minus y1 over x2 minus x1, using the wonderful gradient formula. Try to think, what is negative 1 subtract 1? Something you could do. Yep, it's negative 2. So negative 1 minus 1 is negative 2, is basically all we've done. Negative 1/2, you could change it to negative 0.5 if you like. You could also just go straight to cross multiplying. You could have had negative 1/2 here and you could have cross multiplied. That's also a good way to solve. I just happened to do it this way when I wrote this up. So negative 0.5, you would have to now multiply both sides by negative 2. Negative 0.5 multiplied by negative 2 is 1. And then you've still got negative 3 minus t. And now you've just got to solve for t. So solve for t. Try to think what we need to do. We'll need to first of all maybe add 3 to both sides. So let's do that. So we've added 3 to both sides. And what is 1 plus 3? Of course, it's 4. So 4 equals negative t. So what do you do now to solve for t? You just divide both sides by negative 1. Or multiply them by negative 1, same thing. Divide both sides by negative 1. You would get negative 4. So that's the answer to this one. So we've ended up finding that t is negative 4. Always go back and see, have we got our final answer? Yep, they just want us to find t. That's all they wanted us to do. So we've solved for t. Now let's go on to another problem. So given the points A, B, and C, and D, find t if... So notice, where is t to begin with? We've got these 4 coordinates, but it's coordinate D where t is missing. Find t if AB is parallel to CD. So remember, if they're parallel, then they have the same gradient. But what is the gradient of AB? So that's something we would need to work out first. AB, so label AB x1, y1, label x2, y2, and then plug them into the gradient formula, rise over run. So what is the gradient formula again? That's right, it's m equals, well, m of AB this time, use lowercase m for gradient. The gradient of AB is y2 minus y1 over x2 minus x1. So let's plug those numbers into the formula and work out what the gradient is. So 0 minus 3 is negative 3, negative 1 minus 1, negative 2. A negative divided by a negative is a positive. And I just left it as 3 over 2 here. 1.5 or 3 over 2, both answers are okay. So we've got the gradient of AB. So what does that tell us about the gradient of CD? So CD must have the same gradient as AB. So we can use CD, we can set up the gradient formula for CD, and then set it equal to 3 over 2 and solve for t. So gradient of CD must be 1.5 or 3 over 2 as well, as they are parallel. So now what we've got to do is just what I said. So take the gradient formula, so y2 minus y1, this is using CD. y2 minus y1 over x2 minus x1. If you had it equal to 3 over 2, that might actually even be better. Have it set equal to 3 over 2, and then you could just cross multiply. Bit easier, good to practice your cross multiplication too, so maybe you want to do that instead. I just happened to set it equal to 1.5. So if I do that, I basically now need to multiply both sides by t minus 6. But to do that, I need to write it like this: 1.5 brackets t minus 6 equals, and negative 1 minus 4 is negative 5. Then we need to expand this out to some extent. So then you would end up getting, oh, actually what I did, you could have expanded it, that's fine. But notice what I've done is I've divided off the 1.5. So instead t minus 6 equals negative 5 divided by 1.5, which is negative 3.3 recurring. And therefore, now to solve for t, we just need to add 6 to both sides. So add 6 to both sides. Here we go. T equals negative 3.3 recurring plus 6, which would give you 8 over 3. Or I think it's at 2.6 recurring, same thing. Bit of a tricky one because you're dealing with decimals and fractions and that kind of thing. So 3 over 2 being here, it might have been easy to cross multiply, so feel free to try that out. Cross multiplication, and you should get 8 over 3 as your final answer as well. So same thing again, find t, but in this case, if AB is perpendicular to CD. So what was the gradient of AB again? It was 3 over 2. So if it's perpendicular, what's the relationship between the gradients of the two lines? That's right, they would be the negative reciprocal of each other. So negative reciprocal, so you need to flip this and change the sign. So what would be the negative reciprocal of this? That's right, it would be positive 2 over 3. So here's the gradient of AB, negative reciprocal. So the gradient of CD must be the negative reciprocal of this one, negative 2 over 3. Now we just do that again, set this one equal to the gradient of CD. So C y2 minus y1 over x2 minus x1. And what you could do is multiply by t minus 6. You might, as I said, might want to cross multiply at this point, because cross multiplication actually, to be honest, is probably an easier method here. You can also do what I did, which is fine. But cross multiply is probably what I'd recommend. Feel free to try cross multiplying instead of what I've done and just check that you've got the same answer. So what I did, instead I multiplied both sides by t minus 6, so I took negative 2/3, multiplied by t minus 6, and so on. And then it got a bit complicated, so to be honest, cross multiplication would have been a better method, but I've written this up already, so I'm just going to stick with it. Undo this so you can see it all. So multiply both sides by t minus 6. And then we've got negative 2/3 time multiplied by t, negative 2/3 multiplied by negative 6, which on the side I've shown you. Negative 2/3 multiplied by negative 6, you multiply the top, you get 12. Multiply the denominators, you get 3. 12 over 3 is 4. So that times that gave us 4 equals negative 5. Then I subtracted 4 from both sides, which is what I've done here, and then gave us negative 9 here. Then what I did is I multiplied by 3, so negative 2t equals negative 9 times 3 here, which gave us negative 27, and then I've divided off the negative 2. So t, in this case, ended up equaling 13.5, a different answer. So as I said, cross multiply might have been a lot easier, a lot smoother. Now let's move on to something slightly new, collinear points. Reasonably easy concept though, so we don't spend too much time on it. Collinear points just lie on the same line. So if these 3 points are collinear, it means that they lie on the same line. So these 3 points are collinear. Another way to prove it is, if they're collinear, then the gradient between A and C must be the same as the gradient between C and B, which would also be the same as a gradient between A and B. So, and that's a way of proving that they're collinear by saying that the gradients between all points are the same. So to prove they're collinear, you need to show that the gradient between the points remains the same along the line. So you would need to calculate the gradients to do this. So for example, show that the following points are collinear, A, B, and C, and you've got the whole coordinate for all of them. So now you've just got to work out what's the gradient between AB, what's the gradient between BC, and to prove it as well, you could also find what's the gradient between A and C. So let's do that. Work out if all three gradients are the same. So I did AB first, so I labelled x1, y1, x2, y2, plugged it in. 9 minus minus 1 is 10, 6 minus 1 is 5, you get 2. Then the next thing I did was I found the gradient of BC. So gradient of BC, y2 minus y1 over x2 minus x1, you get 2. So at the moment it's looking possible. The question is implying that they are collinear, but it's always good to check. They could be tricking you. Gradient of AC, you're now using A and C as your coordinates, and we've got 2 as well. So we have, in a sense, just proven that they're collinear, and we should give an explanation of that. As all three gradients are the same, points A, B, and C are collinear, meaning that they lie on the same line. That's what that means. Let's maybe try one more kind of question in that kind of frame before we finish up. Are the following points collinear? If so, why? So try to think, if they're collinear, what's special about them? That's right, they are collinear if all three gradients are the same. And here are the points that these were given to you in the question. You've got the whole coordinates. So again, just use your gradient formula, rise over run, y2 minus y1 over x2 minus x1, calculate the gradient rs, calculate the gradient rt and st to prove that if they're all the same. This point we don't know if they're collinear or not. So gradient of rs, plug in your y2 minus y1, x2 minus x1, we get 1 over negative 9, which is the same as negative 1/9. Next I'm going to find the gradient of st. So let's do that. Feel free to pause and try it yourself first. Gradient of st, it's looking already that they're not collinear because when you plug these in, you end up getting negative 9 over 6, which is negative 3 over 2. So they're already looking like they're not collinear. What's the last gradient I need to find? I need to find the gradient of r and t. So feel free to pause and work that out yourself. Gradient of RT, we got 8 over 3. So you've definitely proven that they're not collinear. So as all three gradients are not the same, they are not collinear. Thank you very much, and that is the end of this lesson.